Lesson 10.2, Product of Powers Property. Alright, I kind of like this section of mathematics because it's just a bunch of number sense, but a lot of rules go along with it. If you'll just take the time to memorize these rules and practice them, it's not too difficult when they're taught in and of themselves, but eventually these are going to start compounding and combining a bunch of the rules together, and that is where it gets complicated. We save more of those for algebra, Algebra 1 next year, but it's important to get these foundation blocks set in place nice and strong so that when that time comes you have stuff to build on. So multiplying powers with the same base is very, very nice because there are special rules that come into play that allow us to basically take shortcuts. We would not want to write this out in expanded form, but if we did, just watch, you don't need to write this, 2 to the 4th times 2 to the 5th would be 2 times 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 2. That's a lot of 2's. I don't know about you. Because this is 2 to the 4th, and this is that 2 to the 5th. That's no fun. But if you go back and you look at this in expanded form, this is going to help you make sense of why the rule applies. Because if you count how many 2's there are 9 of them. And we could go from expanded form back to exponential form. So here's what I want you guys to take away from this. If 2 to the 4th times 2 to the 5th equals 2 to the 9th, what is the rule that we can apply when your bases are the same and you're multiplying them? How did we get this 9 up here? Notice the base did not change. The base stayed 2, but the exponent went to 9. It's pretty easy to see that you simply just added these exponents right here. So if you wanted to, you could write it as 2 to the 4 plus 5 to back up or give a defense as to where 2 to the 9th is coming from. Go ahead and give that a try here on part B. We have negative 5 times negative 5 to the 6th. And the study tip to the left will be a nice little help here, because if you don't see an exponent written on a base, its exponent is 1. So this is really negative 5 to the first power. So we're going to apply the rule that we just saw. That would be negative 5 to the 1 plus 6. Negative 5 to the first power plus 6, because you're adding those exponents up. Don't need to write it in expanded form. That'd be negative 5 to the 7th power. Very good. And since that's a negative, we would want to put parentheses around that. Okay, same thing applies if your base is a variable, because the variable is just representing a number. That'd be x cubed, add the 7, which would be x to the 10th. Done. Okay, so that is multiplying when your bases are the same. You're going to add the exponents. Bases are the same. Add the exponents. If you're making flashcards or coming up with some way to memorize, that right there is key on this first rule. When the bases are the same, you're going to add their exponents. Alright, now we're going to another rule. Power of a power rule. Power of a power rule is another little shortcut. We could again write this out in expanded form. But remember, 3 times 4, 3 to the 4th power is 3 times 3 times 3 times 3. Now that's one of them. The exponent is telling us that we're going to multiply that by itself 3 times. So that'd be another times 3 times 3 times 3. And then another 3 times 3 times 3 times 3. My goodness, ain't nobody got time for that. Okay, that's a lot of 3's written out there, but if you count how many of them there are, that would be 3 to the 12th power. So my question to you, just like I did on the last one, is how can I go from this original problem right here and get 3 to the 12th? If you said add them, you are incorrect, because that would be 3 to the 7th. In this case, when you have a power of a power, you're going to multiply. So that is 3 to the 4 times 3, which would equal 3 to the 12th. Now, this isn't actually having us evaluate. I know it might be kind of confusing when it says find the power of a power. That would imply give the answer, but we're just focusing on rewriting these. Based off of lesson 10.1, I think you could figure out what 3 to the 12th power is on your calculator, but the question is not asking us to do that. It wants us just to find the power of a power, rewriting it in exponential form, basically simplifying it. So we got 3 to the 12th power. We're going to do the same thing with the w. That would be w to the 5 times 4. 5 times 4 is 20, so this would be w to the 20th power. Now, you have two rules under your belt. Okay? We have the rule here where we added the exponents. This is when you're multiplying. You really want to pay attention to the setup of the problem, because if you don't, you're going to start getting these two rules confused, and you're going to end up multiplying when you should add, or add when you should multiply, and that's no fun to be in that kind of situation. Okay, and here's a third rule. Power of a product. Power of a product, not to be confused with power of a power. Power of a product says take each term inside, which is your product going on. We got 2 times x on A, and we got 3 times x times y on B. Take each part of the inside and raise it to the exponent. In this case, if I rewrote that, that would be 2 cubed times x cubed. Each of those was raised up to that point. If I did that here on part B, that would be 3 squared x squared y squared. Now, the numbers here, 2 cubed, I can actually evaluate out. I can find that. In that case, it would be 8x cubed. 2 cubed is 8, and that would be done. 3 squared, I could get 9x squared y squared, and that would be done. Okay, so power of a product, you got to apply the rules you just did on the other screen, but multiple times. Power of a power, multiply the exponents, and then multiplying when the bases are the same as when you add the exponents. Alright, I want you to take some time here. I want you to just work your problems out, get your answers. I'm going to display the answers here in 1 second. Alright, there they are, number 1 through 9. Go ahead and pause the video, check your answers as you go. If you have any questions on these, come back into class, we can work them out together. But that's going to be it for lesson 10.2, looking at the first few rules of exponents.